So let's do a little bit of algebra review here, and we're not going to do an entire algebra review in this topic. Just want to look really kind of at one particular topic, and that's what happens when we have rational functions. Things like the domain of these functions, if there are ways to simplify these functions, because that's going to be a really big theme for our first unit of calculus here. So let's go ahead and consider a function. Let's consider the function f of x equals x minus 3 in the numerator, and in the denominator we'll do x squared minus 8x plus 15. Now then, when we did rational functions in algebra, one of the big things that you knew from its domain is that for rational functions, the denominator can't equal 0 because we can't divide by 0. So this x squared minus 8x plus 15, that itself cannot equal 0. And as you can probably tell by looking at the denominator, we can factor it out. So let's go ahead and rewrite f of x equals x minus 3 over. This denominator will factor as x minus 3 times x minus 5. We'll talk about the fact that there's x minus 3 in both the numerator and the denominator in a later video here within this topic. But what this tells us, what we know from factoring, is that this means that x cannot equal 3 and x cannot equal 5, because that would give us a denominator that equals 0. So if we list the domain here, and I'll list this one out in set notation, we can say that it is x such that x does not equal 3 and x does not equal 5. And there's a couple of different ways you learn about writing domain. In fact, we'll do interval notation here on our next example, but that tells anyone that it's x such that x cannot be 3 and x cannot be 5. All right, let's take a look at one more algebraic thing we need to consider when looking at domain and range. So let's take a look at the function g of x equals, we're going to put the square root of x minus 1 in the numerator, and we're going to put x minus 2 in the denominator. So right off the bat, we get the same issue from the previous example. We know right now that x cannot equal 2. Otherwise, that's going to give us a denominator that equals 0. So we're going to have to throw x equals 2 out of our domain. But we also have this issue with the square root or the radical. And so another thing to note when we talk about the domain of these kinds of functions, the radicand, which is the term for the expression that's underneath the radical symbol here, the radicand must be non-negative, or another way to say that is greater than or equal to 0. It can equal 0. We can take the square root of 0, but we can't take the square root of a negative number. So that means that I need for x minus 1, the radicand, to be greater than or equal to 0, which implies that x needs to be greater than or equal to 1. So the domain of this particular function, I need for all of my x values to be greater than or equal to 1, but I also need to throw out the value x equals 2 because that makes a 0 denominator. And so to write the domain of this function, I'm going to use interval notation for this one. I need to start off with 1 included, and then I can go up to 2, which needs to be excluded from the domain, so make sure you keep your brackets and parentheses correct. And then I will union that with 2, and then it can go up to infinity. And so that tells everybody 1's included in the domain, 2 is excluded, and that anything larger than 1, as long as it's not 2, is part of the domain. So we'll continue to work with these rational functions and ways to simplify them, but we need to start off by understanding that the domain of these rational functions is still a very important thing for us to consider before we start simplifying.